In organic chemistry, separations can be performed based on chemical and physical properties of compounds and solvents. Non-water soluble organic compounds can be separated from water-soluble inorganic compounds via filtration. Organic compounds can be separated from other organic compounds by converting them to something like a salt, which is water-soluble, using acid-base chemistry and liquid-liquid separation.
The mixture you will be working with is composed of aminoacetophenone, benzoic acid, and sodium chloride. Ethyl acetate is an organic solvent. Some of the mixture will dissolve in ethyl acetate, the organics, and some will not, the inorganics. These can be separated using a solid-liquid separation, otherwise known as filtration. And this deals on the principle of organic solubility. Organic compounds are soluble in organic solvents and inorganic compounds are not. Sodium hydroxide is then going to be added to the liquid portion only, removing an acidic proton and creating a sodium salt. The sodium salt will be water soluble and go into the aqueous liquid, while the organic compound that does not react with the sodium hydroxide will stay in the organic layer. The liquid-liquid separation can be performed in a separatory funnel. To the aqueous layer is added hydrochloric acid, which will protonate the sodium salt. The reformed organic compound is not water soluble, so it can be separated at this point.
Weigh out the mixture and add it to a beaker with approximately 25 ml of ethyl acetate. Stir the mixture well and break up any chunks. The organic compounds should dissolve in the ethyl acetate, which again is an organic solvent. Place the separatory funnel in the ring stand. If the stopcock is in the vertical position, it is open. Be sure to close it so you don't lose all of your compound through the funnel. Decant or pour the mixture into the funnel, leaving the inorganics behind in the beaker. Next, add sodium hydroxide to the funnel. This is your aqueous layer and will contain anything that was deprotonated and is now water soluble. Organic solvents tend to not like aqueous solvents, so you should see a layer of separation. The organic compound that was not deprotonated should remain in the organic layer. Food coloring has been added to make the layer separation more visible. Carefully remove the separatory funnel from the ring stand and cap it. Invert the tube gently a few times and release any built-up gas by opening the stopcock. Make sure to close it again before shaking the funnel with increasing vigor. Place the funnel back in the stand and remove the cap. If you forget to remove the cap, the funnel will be very slow to drain. Collect the bottom green layer only, or the aqueous layer only, in a clean flask by opening the stopcock. Slowly add hydrochloric acid to the aqueous layer to protonate anything that was previously deprotonated by the sodium hydroxide. It is now an organic compound again that will be insoluble in water. Allow it to precipitate at room temperature, then cool it on ice and cool down some water for rinsing later. Set up the vacuum filtration as before. Wet the filter paper with water. Turn on the vacuum, give the flask a good swirl, and pour into the funnel. Use the cold water to get any remaining crystals into the funnel. Recrystallize the product as you did last week. Scrape the crystals into a beaker. Add a very small amount of water and have some water heating in a separate beaker in case you need to add more. Heat the mixture of water and crystals and add hot water as needed to dissolve the crystals. Remember to add a minimal amount of water. Once it is dissolved, cool to room temperature, then cool it on ice and filter again. Don't forget to get a mass and a melting point to confirm the product's identity.